Are magnetically levitated vehicles actually possible? Fuel me once here, driving instructor of the world. Some of you have noticed we've done a series of alternative fuels and fossil fuels here, and a couple of you have asked about magnetic cars. Now, while all motors with engines use magnets, especially electric engines, I think what you really want to know is that the maglev vehicle that's possible, magnetically levitated, kind of like the trains they use in China and Japan. Maglev trains use electromagnetic force to have trains levitating several centimeters above their tracks, overcoming gravity, no physical contact with the tracks, no friction, enabling speeds of more than 400 miles per hour. That turns like a 5-hour commute into like 40 minutes. Problem is, it would require a complete reinvention of the world's infrastructure. Now, there used to be some low-speed maglev vehicles in England and Germany, but those don't exist anymore. As to the adaptation for roadway vehicles, right now we only have models that are 12 centimeters long and 4 centimeters wide. That's it, on a 10-meter long track. However, recent study in superconductor science and technology showed that the models demonstrated significant stability advantage over what we have currently, but of course at a much smaller size. Scientists use specially fabricated high-temperature superconductors for the cars and permanent magnets on the tracks, which demonstrated a levitation force and greater stability than when permanent magnets are used on both the car and the track. In this recent model, the cars are propelled by a combination of linear motors on the tracks and aluminum rotors on the vehicles. Then photoelectric switches near those linear motors on the track save energy by ensuring they only turn on when the rotor comes near or travels right through them. Then there's large magnetic forces across the track, which ensures the car stays within the boundaries. Because that magnetic configuration provides a large dragging force, it eliminates any need for any kind of external stability control. And one drawback is you got to have liquid nitrogen to cool to about negative 196 degrees centigrade so that the levitation and guidance forces are optimized. Now look, this needs a lot of further investigation, and we're basically a long way away from a life-size model. Also, the issue of would the world be willing to completely reinvent its infrastructure? That's billions to revamp every road. And also, who's going to own these vehicles? We're going to investigate in the next couple days what your government thinks about private ownership. Meanwhile, drive kind. You only have your magnetic personality to go on. Thank you.